May 2023 IB Maths paper, AASL Time Zone 2, Paper 1. Question 9. A circle with equation x squared plus y squared equals 9 has center 0, 0 and radius 3. A triangle PQR is inscribed in the circle with its vertices at P minus 3, 0, Q, x, y, and R, x, minus y, where Q and R are variable points in the first and fourth quadrants respectively. This is shown in the following diagram. So part A, for point Q, show that y equals square root of 9 minus x squared. So point Q lies on the circumference of the circle. So because of that, you can just use the equation of the circle to figure out the y coordinate. So the equation of the circle is x squared plus y squared equals 9. At point Q, the x coordinate of Q is x. So all you have to do is rearrange this equation, make y the subject. So y squared is 9 minus x squared. So y equals the square root of 9 minus x squared. B. Hence, find an expression for A, the area of triangle PQR in terms of x. So the area of a triangle, A, is half base times height. So in this case, I'm going to say that QR is the base of the triangle. Both the coordinates of Q and R have x coordinate x. So this means that the line QR is perpendicular to the x-axis. I'm going to call the point at which the line QR cuts the x-axis as M. Okay, so now I need to figure out the coordinates of M. So the the x coordinate of M is x, because M is collinear with Q and R. So M equals x, comma, and the y coordinate is 0 because QR cuts the x-axis at M, so the y coordinate must be 0. So knowing that M has coordinates x, 0, this means that the distance from M to Q is y, because the y coordinate of Q is y. So from here to here is y. But also the y coordinate of R is minus y. So from M to R is y again. So the total distance from R to Q is y plus y, or 2y. So the base of the triangle, B, equals 2y. Now to work out H. And H is the distance from here to here, and then from the origin to here. So from point P to the origin is 3, because P has x coordinate minus 3, so there to there's 3. So it's 3 plus x, because the x coordinate of M is x. So here to here is x, here to here is 3, so 3 plus x is the height of the triangle. H is 3 plus x. And H is the perpendicular height, since QR is perpendicular to the x-axis. So I'll put in the right angle symbol there. Okay, so H is 3 plus x. So putting these figures into the area formula. So it's a half multiplied by 2y multiplied by 3 plus x. But the question wants an expression for the area in terms of x only. So we'll use our answer to A and substitute y as root 9 minus x squared into here. So A equals a half multiplied by 2 root 9 minus x squared multiplied by 3 plus x. And then simplifying that a little bit, half times 2 is 1. So you're just left with root 9 minus x squared times 3 plus x. And then just looking ahead to part C, C involves differentiating our expression for A. So I will rewrite A as 9 minus x squared to the half multiplied by 3 plus x. Because the way you differentiate roots is by changing them into fractional powers. So the square root of 9 minus x squared is the same as 9 minus x squared to the half. So that's the expression for the area A. Now part C. Show that dA by dx equals 9 minus 3x minus 2x squared all over root 9 minus x squared. So the starting point is writing A again equals 9 minus x squared to the half multiplied by 3 plus x. So this expression for A is a function, 9 minus x squared to the half, multiplied by another function, 3 plus x. And when you're trying to differentiate a function multiplied by another function, we use the product rule. And the formula for the product rule is in the formula booklet, and it's this. So dy by dx equals v du by dx plus u dv by dx. In this case, 9 minus x squared to the half being u and 3 plus x being v. Okay, so u equals 9 minus x squared to the power a half, v equals 3 plus x. Differentiating 3 plus x is far simpler than differentiating 9 minus x squared to the half, so I'll do that first. So if v is 3 plus x, dv by dx equals 1. Okay, so if u equals 9 minus x squared to the half, you can differentiate this using the chain rule, but there's a shorthand version of the chain rule that you can use that saves you a lot of time. It's very simple to use. And it's far, in my opinion, it's far simpler than going through the whole rigmarole of chain rule differentiation. And I'll put an aside here on how you do that. So say if you have a function in the general form y equals some constant a multiplied by a function f of x to the power b. So in this case, a will be 1 because it's like there's an invisible 1 in front of here. F of x is 9 minus x squared, and b, the power, is a half. So this is a general rule for differentiating expressions of this form. So dy by dx equals ab, so a multiplied by b, multiplied by f of x unchanged to the power b minus 1, and then all of that multiplied by the first derivative of f of x, so multiplied by f dash x. This can always be used in place of the chain rule, unless the question specifically says that you need to use the chain rule to differentiate something. But if it doesn't say that, you can use this method, and this always works. Okay, so applying that here to this example. So if we'll do it here, so you know u is 9 minus x squared to the half. So du by dx equals, just scroll up a little bit. So du by dx equals ab, a multiplied by b. So in this case, it's 1 multiplied by a half. So a half multiplied by fx, unchanged. So that's 9 minus x squared. To the power b minus 1. So it's the power a half minus 1 multiplied by f dash of x. So inside of the brackets differentiated, which is minus 2x. So then tidying that up a little bit, so du by dx equals half multiplied by minus 2x is minus x multiplied by 9 minus x squared to the half minus 1 is minus a half. And I'm going to rewrite that as a fraction. So du by dx equals, rewrite minus x as minus x over 1. And then 9 minus x squared to the minus a half is the same as 1 over 9 minus x squared to positive a half. Then multiplying this out, you get du by dx equals minus x times 1 is minus x over 1 times the 9 minus x squared to the half is just 9 minus x squared to the power a half. Okay, so now we have all the elements for differentiating a. Using the product rule. So dA by dx equals v du by dx plus u dv by dx. And here, dA by dx equals v, which is 3 plus x. Du by dx is here. So v is 3 plus x multiplied by du by dx, which is minus x over 9 minus x squared to the half, plus u, which is 9 minus x squared to the half, multiplied by dv by dx, which is 1. So dA by dx equals, I'll just make that a little bit neater. Three plus x. So I'll change this to 3 plus x over 1. And then you just use the rules for multiplying fractions, top times top over bottom times bottom. So minus x times 3 plus x over 1 times 9 minus x squared to the half, so 9 minus x squared to the half, plus 9 minus x squared to the half times 1, which is just 9 minus x squared to the half. Okay, so that's expression for dA by dx, but the question wants dA by dx in a slightly different format. So part C says that show that dA by dx equals 9 minus 3x minus 2x squared over square root of 9 minus x squared. So we're almost there, because we do have 9 minus x squared to the half in the denominator here, which is the same as square root of 9 minus x squared. So all you have to do to arrive at the expression that they want is to rewrite this part, 9 minus x squared to the half, as a fraction over 9 minus x squared to the half. And you do that by rewriting it as 9 minus x squared to the half over 1, and then multiplying it by 9 minus x squared to the half over 9 minus x squared to the half. So then that means that dA by dx equals, expand this bracket, so minus 3x minus x squared over 9 minus x squared to the half, plus 9 minus x squared to the half times 9 minus x squared to the half is just 9 minus x squared. The square root multiplied by square root cancels out the square root, and you're just left with what was underneath the root. So plus 9 minus x squared over 1 times 9 minus x squared to the half is 9 minus x squared to the half. So this can now be rewritten as a single fraction. So it's minus 3x minus x squared plus 9 minus x squared all over 9 minus x squared to the half. So dA by dx equals 9 minus x squared is minus 2x squared minus 3x all over 9 minus x squared to the half, which I'll just rewrite as the square root of 9 minus x squared. And that's the form that they wanted you to have it in. So 9, just checking that again with the answer. 9 minus 3x minus 2x squared over root 9 minus x squared. Slightly different, but I'll just rewrite it. 9 minus 3x minus 2x squared over root 9 minus x squared. Okay, part D. Hence or otherwise find the y-coordinate of R such that A is a maximum. So as soon as you see the word maximum or minimum in a question like this, which involves differentiation and algebraic expressions, this is relying on the knowledge that at a maximum or a minimum, you're dealing with the stationary points of your expression, and at the stationary points, the value of dy by dx is 0. Because at dy by dx equals 0, you can have a maximum, a minimum, or a point of inflection. In these questions, it's typically not a point of inflection. It's usually a maximum value or a minimum value. So in this case, we'll be solving dA by dx equals 0 as the first step towards working out the y-coordinate of R such that A is a maximum. So we say dA by dx equals 0. Okay, so dA by dx equals 0 at maximum point. So that means that 9 minus 3x minus 2x squared equals 0. Because when you have an expression that is a function over another function, so in effect a fraction, the denominator of the fraction can never equal 0. So you're not trying to solve root 9 minus x squared equals 0. In effect, you ignore the denominator and you just solve the top of the fraction equals 0, which is what we have here. 9 minus 3x minus 2x squared equals 0, which is a quadratic expression. Since this is paper 1, non-calculator, this highly likely involves factorizing. And it's much simpler to factorize a quadratic expression when the coefficient of x squared is positive. So to make this positive, we're going to multiply everything by minus 1. So multiplying everything by minus 1 gives minus 2x squared times minus 1 is 2x squared. Minus 3x times minus 1 is plus 3x. 9 times minus 1 is minus 9 equals 0. So factorizing quadratics involves two sets of brackets equaling 0. And then the quantity that goes here and here, they must multiply to make 2x squared. So that will be 2x and x. You could also have had x here and 2x here, but the order doesn't matter as long as they multiply to make 2x squared. So I've put 2x here and x here. And then the values that go here and here must multiply to make minus 9. So there's several choices for that. You could have minus 9 multiplied by 1, or minus 1 multiplied by plus 9, or 3 multiplied by minus 3. I'm going to try minus 3 and positive 3, but to start off, I'll just put a 3 here and a 3 here. because this multiplied by whatever this is, plus this multiplied by this, must combine to make plus 3x, as well as multiplying to make minus 9. So if I say this is plus 3 and this is minus 3, so then working backwards, minus 3 multiplied by plus 3 is minus 9. 2x multiplied by 3 is 6x. Minus 3 times x is minus 3x, and 6x minus 3x is plus 3x. So that is this expression factorized. And now solving this, so this expression equals 0 if the first bracket equals 0, or if the second bracket equals 0. And the first bracket equals 0 when x equals 3 over 2, because 3 over 2 times 2 is 6 over 2, which is 3. 3 minus 3 is 0. And the second value is x equals minus 3, because minus 3 plus 3 is also 0. So these are the two solutions to dA by dx equals 0. So we're going to go back and have a look at the diagram to see which one of these gives us a maximum value of a. So either 3 over 2 or minus 3. So going back up. Okay, so we'll start with minus 3. So if the x-coordinate of r is minus 3, that would place r over here. Q would be up here, also at minus 3. So that would make Q, P, and R collinear, and the triangle will be reduced to essentially a straight line. So that looks far more like a minimum area than a maximum. However, if we choose x is 3 over 2, then the x-coordinate of r would place r on this side of the y-axis, so somewhere over here. And that looks far more likely for creating a maximum area, r being on this side of the y-axis rather than this side. So we're going to choose 3 over 2 as the x coordinate of r, and if x is 3 over 2, then the y coordinate of r is minus y, and we know that the y coordinate of q is root 9 minus x squared. So the y coordinate of r is just the negative of this because it's minus y. So we're going to pick x is 3 over 2, and the y coordinate of r is minus root 9 minus x squared. Okay. So x is 3 over 2, and we're using y equals minus square root 9 minus x squared. So that means y equals negative square root of 9 minus 3 over 2 squared. So y is the negative square root of 9 minus 9 over 4. Y equals the negative square root of, so to subtract 9 over 4 from 9, I'm going to rewrite 9 as a fraction over 4. So 9 as a fraction over 4 is the same as 36 over 4 minus 9 over 4. So y equals negative square root, 36 minus 9 is 27 over 4. So finally, the y coordinate of r is minus square root of 27 over 2. So I hope you found that helpful, and if you did, then please like and subscribe, and I'll see you at the next one.